Hello everyone, I'm going to be doing a presentation of a geologic tour of the Rodeo Hercules and Pinole shoreline of San Pablo Bay. So let's begin. Here we have a geologic map um, of the area, and on it I labeled with the blue numbers different stations as we would begin walking along the shoreline, starting just a little bit away from the shore, not too far from where I live. And let's see what we can encounter along the way as we walk along the shores of San Pablo Bay. Here's our station one. We see a pretty weathered outcrop of a pinole tuff. It is at the terminus of a Vaqueros Avenue and Mariposa. It is very weathered, very crumbly. Um, for what is on a surface, it is difficult to assess the dip and strike, and anything would help us to orient this particular outcrop. But there it is, just for the reference. So there's not much more I can say. So let's continue walking. Here is station 2. Again, we see another outcrop, even smaller, more weathered. Um, again, very similar to what I said the previous one. It is a pinole tuff. It's a volcanic ash. I cannot assess whether it's reworked or not. Maybe if I can get a fresher sample that's a bit deeper in, less weathered, might be able to tell more, but at the moment it is what it is. So let's continue moving along, because there'll be more interesting and more definitive things as we move along, approaching the Rodeo Beach. Okay, here, before we move on, I wanted to focus first on the right. We have a satellite image of a shoreline, and we can see where it says Rodeo Beach. We see Four Falls Winery, and that's a marina in Rodeo. And there's a railroad track running along the shore, and right next to it there is a trail. Um, in the red lines, I emphasized uh, the uh, the beddings that exist in different outcrops um, that are visible in between. Uh, there is nothing that can easily be seen. Maybe on a very low tide, something can be seen. But what we're seeing is, if we look on the left, uh, we see there are different beds that tilted to about 30 degrees, uh, and a strike is oriented more or less uh, north, um, north slightly to the east. And what we're seeing is the different beds have different hardness and eroded differently, and the softer ones eroded a little further down than the harder ones, and this creates this effect of these ridges that protrude out of a wave cut platform. And if we extend them on the various ones we can see around the Rodeo Beach, for Falls Winery, that they were actually used in the early 20th century and the late 19th century as a basis for piers. Many piers along the area would extend at approximately the same angle. Um, so that this tells us that although we do not see them being continuous, we can infer that perhaps they are continuous beddings even in an area where they're not visible. So knowing that, the dip and strike, and assuming based on based on a strike that they're more or less the same, we can infer original horizontality principle and assume that as we go from north to south on the map, it means from the top to bottom. As we go from station 3, 4, 5, and 6, that we're going to be getting an older sediment and older rocks. So I wanted to review this before we move on to the station 3, which is at Rodeo Beach. Here is we see from cliff Rodeo Beach those tilted beds that tilted that the the deep angle is around 30 degrees. I had not personally measured. It's in eyeballing, but for today's presentation it is good enough because most of the beds are tilted to approximately the same angle. We can see on top of it there's a layer there's a layer of soil that began to be formed, and on the left we see that it is deposits of ash, volcanic tuff. The way that it cracks in this blocky, chunky way might infer that it also has quite a bit of clay, so maybe it is a mixture of a tuff and a mudstone. So this is what we can tell from what we see on the pictures. Next, we again have a station 3. There are more interesting things. We see on the left, there's my daughter. On top of the bed, there's a layer of a shell hash that's about half a meter to a meter thick. It's in one area, so it definitely happened after the beds were tilted and began to erode, but before the formation of the soil over them. So this would reflect the change in ocean level in the area, and there should be rather recent, maybe dating back to the Pleistocene. I could not find particular dating to this area, to this shell hash. I'm just inferring from the dating of a volcanic tuff below it. On the right, again, we see those tilted beds. It's not as obvious, but you can still see it. And above, there's a thick layer of soil, and in between and at the bottom, you see occasional patches of a shell hash that are also visible, and you can see where the beach level is. So it is about maybe up to 10 meters above the current level of the bay. So that indicates the sea level change in the area that was relatively recent. Let's move on to the next slide that is as well from this station. Here we see one of the beds, and it is an outlier in the area, is this one thick bed that is full of scallop shells. And this is the picture of the top of the bed. Towards the bottom, the thickness of this bed is over a meter. Perhaps it reaches up to 2 meters in places. Towards the bottom, we can see more broken shells and more sandstone, more sand grains in between. But towards the top, especially if you can see in a top left corner and top right corner, we see the edges there. They're really stacked up. It's mostly shells, and I had been there to this area many times. I had not seen any other organisms, any other shells apart from these. So it is a curious thing why there's this single species and no others that can be found, unlike some other areas that we were going to visit on our station as we move along. So this is something that would require more studying, and definitely an outlier in the area. Perhaps just my idea, that it might have some relationship to the volcanism that happened in the area. Maybe it's a result of die-off as a result of eruption um, that created this particular bed. Maybe not, but let's move on. In station 4, as we move south, we don't find any more ash. We don't have any evidence of volcanism. What we do find is a sandstone. So sandstone beds that again tilted and oriented the same way as the station 3. This area is about half a mile away along the shore from the previous one. In this area, however, it's distinct because it has a lot of concretions, and these concretions they have calcium carbonate. You see in bottom left picture, there's a cross section where the concretion broke off, and you see this whitish stuff. If you put something acidic, such as diluted HCl acid or white vinegar, it will fizz. So this is what they're reaching, calcite probably. And on the right, you see my daughter. It's a horizontal slice of this concretion. They look very interesting, like this worm-like structures that go in and out. And this area had not been able to find any fossils, at least not fossils that are visible to the naked eye. And the beds there consist of a coarse to fine sandstone. And that's pretty much the highlight of this particular outcrop. So let's move on to the next station. Station 5 is about a quarter mile south, and here where we see something that from a standpoint of fossils is more interesting. We see again in this area, in this outcrop, there's no evidence of any volcanism. The beds, again, the oriented dip and strike is very similar to the all others, as I mentioned, and I'll try to reiterate because to me it is a sign of some relationship that I'm trying to establish. Maybe I'm right, maybe I'm wrong on this one. This is areas composed of a sandstone, fine-grained sandstone that intercepted by the thin, relatively thin, and beds that appear to be pinching off. However, I do not see the end of it just by changing thickness. And here you see it's a very coarse acoustic sandstone. And by the fossils that I seen there, this one, unlike the previous bed at Station 5, this would be reminiscent of a more of a typical shoreline where we see more sand and some shells, broken shells. However, in this area, besides the bivalves and gastropods, we also find sand dollars. So that gives us a definitive answer that this was not a estuary, there wasn't a bay, that was a marine environment, and this is another clue to the puzzle that we're trying to solve here of what happened and how it is related to the other beds around it. And in this area, we have a few beds, perhaps 6 or 7. We see a fine-grained sandstone, then you see this fossiliferous sandstone bed that ranges from a few centimeters to maybe 30 or 40 centimeters thick at its thickest, and then we again see a thicker layer. Hard to see the layering in those beds, but it's more finer sandstone. It means that perhaps the area getting way deeper because we have a fine grain material and we don't find any fossils. and then again it alternates, and this is the pattern in this particular outcrop. So now we move south, again south and southwest, um, along the shore, and this area is a little bit further away. In between the Station 5 and Station 6 there was quite a bit of a development along the shoreline of San Pablo Bay in Pinole. There was a Pinole Wharf, so a lot of areas were modified. If there were any outcrops, maybe they were removed. Um, um, so I could not find, since they were, if they were there and they were leveled, and now it's grass growing over it. There's nothing that I could see without any sort of digging. So this area is about a mile away from the Station 5. Here we see again the dip and strike of the layers is about the same. It is not as obvious, but maybe you can see by the on the left picture, the steer orientation is parallel. And the sediments here are very similar to what was at Station 3 at Rodeo Beach, which is appears to be tough, but perhaps has some mudstone in it, some mixture of both, because the way it weathers in a blocky fashion, and it's actually a bit distinct from the tuff that we saw in Station 1 and 2, which when it weathers it just crumbles into dust. This one breaks into this chunky blocky pieces, which suggests it probably has a lot of clay in it, and probably a mixture of ash and mudstone. So occasionally in this area we can find imprints and casts of closed bivalves. So not many. So cannot say more about what kind of environment it might have been, and there's what I can say at the moment at this station. So let's continue walking in the direction towards our Station 7. Here we get something that is more interesting in a way. We see that again, tilted beds, dip and strike is about the same as the areas before that. However, on a picture on the left, if we look close, we see an alternating layers of a coarse and fine volcanic material. There's a volcanic, and the way that the beds orient might have suggested it's a reworked tuff that have some fluvial structures that might suggest that, but just seeing the difference in a coarseness of a material would suggest the different stages of eruption. But since it's reworked, it's harder to assess what the aging difference without radiometric dating of each layer, whether they are spread out over thousands years, or whether it was a single eruption or over a couple of years. So that's an interesting thing. But the larger fragments would probably measure about a centimeter or two across. So it's getting coarser, but not too coarse, unlike the next station that we would see next. All right, here we are at a Wilson Point. This area protrudes as a little peninsula, and again, on the picture on the right, we can see the dip and strike of the bedding. Very clearly visible and cohesive with all other stations that we passed through before, except for 1 and 2, because we could not ascertain the dip and strike at those outcrops. This one, however, if we look on the picture on the left, I'm indicating has larger fragments embedded in a tuff, and they are different in color. You can see some of them are very light, so some of them are very dark. That is also would be interesting to collect more sample and analyze for the composition to see what makes the difference. And just by straight interpretation, if we get coarser material, we're getting closer to the source of eruption, unless this is a reworked tuff and a water washed it to this present location. This would require further analysis, but that is the area at this station. Another interesting feature at the Wilson Point is we have evidence of an ancient riverbed. You can see it on the top right corner. We see this concave structure, and it cuts across the volcanic deposits, which means that it happened after the layers were formed, tilted, because we see that the river channel, as far as what is exposed, it's pretty close to horizontal, but the beds are tilted, so it was definitely not the feature that happened at the same time as the formation of the beds. So the beds formed, tilted, got eroded, and this stream cut across them. The interesting thing here is on the left we see on the right is a riverbed. On the left is what was the shore of the stream, or perhaps one thing that is noticeable. I'm still trying to they have some ideas what it might be. We have a shell hash. It's not as dense as the one we saw at station 3. So what we see that on the right we see rounded pebbles and cobbles that indicate that this was a riverbed. They're rounded, they're pretty well polished in places, although some angular. So there could be two possibilities. One is that this was some sort of a estuary. No, not estuary. It was where the river or creek would meet the bay, where we see these shells, or this shell hash was formed prior, and there was some change in as we saw them in station 3, where we saw shell hash and a creek cut across. These layers where there are shells, unlike the volcanic ash right below it, is unconsolidated, so it looks like just a dirt full of shell fragments. So another possibility is that this layer of unconsolidated shell hash formed prior the formation of the creek, and the creek just cut across this unconsolidated layer down and cut across the volcanic tuff as well. Another notable thing from this area is you see on the right there's a wood fragment that I found. So that would other interesting things that you can find. I found a couple other things that I'm still working on trying to analyze of what they might be, but curious nonetheless. So we're approaching the end of our tour. Let's move on to the station 9. Station 9 is very close to station 8. It's about a quarter mile away, and here again we stop seeing the evidence of any volcanic activity. There's no tuff, there's no ash, nothing that would indicate volcanism, and we get back to sandstone. However, in this area there are these interesting formations concretions, whether they are these ones are different from the ones we saw at the other station, at the station number 4, as these look tubular and vertical. So maybe there were concretions that formed as the sediment filled the burrows of some animals, or there's another process that created them. Again, something that worth investigating and a curious thing nonetheless. And that's a highlight of this station. There are no other features that I can find to apart from saying that we stopped seeing the volcanism here, and that's the end of our tour. Here is my citations. This is the map and some of the material that I read for the penaltuffs and the different different beddings that are in the area, which unfortunately has still a lot of holes. So there's much to be investigated and still learned, plus the map of the area of Wilson Point. As we can see, as we saw, it had only the volcanic deposits. The map, however, that we saw at the very beginning marked those areas as alluvial sand and gravel, which we do not see in the area, which is, a curious thing why it was labeled that way. So still a lot to learn, a lot to investigate, and a lot of material for future projects. Thank you for staying with me and watching this video through the end, and have a good day.